Okay, we're going to go over this navigation question again. And an interesting thing about this question is I found an important issue. So when we went over this, there was a reason that this was wrong. And it's because it's not to scale. And it's still not to scale. However, compare the difference in pictures. So this is a correction. It's a navigation example. We're going to go over this again, and let's look at the details again. Okay, so we have a fisherman leaving a home port. So here's the home port and travels north 70 degrees west. North 70 west. So in this picture, north 70 west, this angle would be 70 degrees. And travels for 40 miles. And is heading to Egg Island. So we say, okay, here's an Egg Island over here. So let's make sure we have that, and I think we do. The next day travels north 65 degrees east. So let's look at what that is. Travels north, east, and I guess this portion here is, 65. So I don't know, maybe we'll change that color. So here's our 65 degrees. Traveling northeast. And going for 60 miles now. And of course, reaching the destination known as Forest Island. And I guess we'll just color that gray. All right. So now, here's the question. Find the distance between the home port and Forest Island. So that's still the same. We want to know what D is over here. So they're just asking for this distance over here. Okay. So it looks like this is kind of the information they gave us. And again, some of the details here, just like before. The devil's in the details. I guess we'll use a different color. This angle out here, that's 20 degrees. Okay, because it's complementary to the 70-degree angle. And this angle here is 20 degrees. So, okay. But we also need to know, and let's remark that this angle here is complementary to the 65-degree angle. Now, what I want to remind people is 90 minus 65 is in fact 25 degrees. Okay, so this is 25 degrees, which now makes us have a triangle here. That's a 45-degree angle. And this is the information we're going to use now to find the distance by law of cosines. Okay, because we have again now a side situation here, law of cosines. So we're going to find that distance the same way we did, but that is in fact a 45-degree angle. So I just want to make sure we go through these corrections so you guys can see how to do this now. All right, side angle side, law of cosines. So law of cosines says simply the following, right? It's d squared is a squared plus b squared minus 2ab cosine of the angle theta, where these have to be opposite. In other words, the 45-degree angle and your distance d, notice they're opposite each other. And the 60 and 40, these are the legs in law of cosines. So in law of cosines, d squared will be 60 squared plus 40 squared minus 2 times 60 times 40 times cosine of 45 degrees. So 45 degrees in D. So we're going to find that. Square root 60 squared plus 40 squared minus 2 times 60 times 40 times cosine 45 degrees. And we're going to see what D becomes. And this is again by law of cosines. So let's take a look at the TI. Square root 60 squared 40 squared minus 2 times 60 times 40 times cosine 45 degrees. We get 42.5 miles. And there we go. So excuse me, 42.5 miles. So we're going to put that there. Okay. Okay. So now we have another question. So we know this distance D already. That's 42.5 miles. And they say find the bearing from Forest Island back to Fisherman's Port. So in purple, find the bearing from Forest Island. Okay. Back to the home port. So it looks like we're going to have to double check here, right? So we left the home port, went to Egg Island, went to Forest Island. So we're going from Forest Island back to the home port, right? So we're going from here now. We're in Forest Island. We have to get back to the home port, back home. So we're going to have to travel southwest, ladies and gentlemen. So this picture is more realistic here. This is south theta west. So here's what I want to say. You're having to go now southwest. Okay? And this is the angle that you need to remember we have to find. That's where your theta is. That's the theta. And that's the same angle right here for theta because you have a transversal. So right in there is your theta, ladies and gentlemen. You have a transversal. Okay, now here's what I want to remark, and here's the key. Take a look. We're going to call this position here home port. That's a vertex A. Vertex H. We'll use H, not A. H for home port. We don't have to use the A vertex. We use H for home port. I think it's easier to remember. Now, what I want to point out here, this is really what we got to do. It's right in here. I'm going to write down an equation here that 70 degrees plus, and maybe change the color. You can see what I'm saying. 70 degrees plus that theta is equal to angle H. Take a look. The 70 plus theta, well, that's angle H, which means now that the theta angle that I'm looking for in purple is equal to angle H minus 70 degrees. So that's what I'm trying to find, ladies and gentlemen. That's the key. Now, let's be very, very careful here, right? If you go back to the law of cosines now, law of cosines enables us to find an angle if we can solve for theta, and we can, but we're really going to solve for cosine theta first. Now I'm going to translate, use a technique for solving equations known as moving terms to the other side, and if you do, you change the sign. So fine. So I have two. Let's do some algebra. 2ab cosine theta becomes a squared plus b squared minus d squared. Cosine theta is a squared plus b squared minus d squared over 2ab, which means theta is inverse cosine a squared plus b squared minus d squared over 2ab. So this is what we're going to use to find angle H. But remember, angle H and D have to be opposite each other. This is the essence of law of cosines. So when I go back to angle H, right in here, what I need to find, my D there is 60. And the other values in this triangle are the legs. The other values of the legs, so it's going to be 60 for D. Okay. So angle H inverse cosine minus 60 squared over 2AB. Now remember what A and B are. 40 and 42.5. Those are the legs. 40 and 42.5. So 40 squared plus 42.5 squared. 2 times 40 times 42.5. Let's get this going here. Yeah. Here we go. Let's find what angle H is. Inverse cosine. Let's put another parentheses. 40 squared plus 42.5 squared minus a 60 squared. Close that, divided by 2 times 40 times 42.5. You close that twice. And ladies and gentlemen, you get 93.3 degrees. Okay, now let's just kind of, I guess we can go with 93 degrees. Okay, it's going to approximate just as an exercise. In reality, we probably have to be much more accurate than that to guarantee we get home, or at least in sight of home. So this is an important thing that we found. Angle H is 93 degrees. So what I mean by part of the issue that we had in the past was the picture was just not to scale. You know, this angle H is 93 degrees. Now that kind of makes sense. The picture does make sense now. So I just want to let you guys know that's kind of the deal. You know, and this is 93 degrees. 93 degrees. Now this makes sense because 93 degrees minus 70 degrees simply means that that angle theta will be 23 degrees, ladies and gentlemen. So what this now means for us is we have found here what we're looking for. 23 degrees. So we have to go southwest 23 degrees from Forest Island to get to the home port. And that's how you go about this question here. So here's a correction. I just wanted to make sure you guys know that the picture was off, which was kind of a little confusing. And we did another small error. But hey, that's what happens when you wake up early and you have an early math course. We still have to wait till the coffee kicks in. So anyway, south 23 degrees west. We have that correction for you guys. I hope you guys have a great day. Stay safe and take care.